Hyperbolas. A hyperbola is the set of all points P in a plane such that the difference of the distances between P and two fixed points called the foci is constant. Now, first of all, the biggest difference here is that we're talking about the difference between the 2 points. If you remember back to an ellipse, it was the sum. So this time we're talking about the difference. A hyperbola is going to look something like this. Your foci are going to sit out here. If you pick any point on your hyperbola and you find the first distance and the second distance and you subtract them, you're going to get a number. Then if you pick any other point on your hyperbola, find your first distance, your second distance, and you subtract them, you're going to get the same number. Then when you take them all and put them together, you get this shape that looks something like this, which is called a hyperbola. Now, the line through the foci intersects the hyperbola at the two vertices. The transverse axis joins the vertices, and its midpoint is the hyperbola's center. So, if your foci are on your x-axis, then your transverse axis is going to go through your two foci. In this case, your hyperbola is then going to be vertical. If your foci are on your y-axis, then this will be your transverse axis, and in this case, your hyperbola kind of lays down and he goes more horizontal. A hyperbola has two branches and has two asymptotes that contain the diagonals of the rectangle centered at the hyperbola center. So then the question becomes, okay, well, how steep or how narrow is my hyperbola? And that's determined by these two asymptotes, which are these dotted lines. Once you know where your vertices are and you find your asymptotes, then your hyperbola just follows the asymptotes through the vertex and follows the asymptotes through the vertex. Now, on our next slide, we're going to look more specifically at our two equations. So let's take a look at our two equations. First of all, do you notice, same as an ellipse, it has to equal 1. That's a biggie. If it doesn't equal 1, we have a problem. The next thing is that we're now subtracting. Okay, and if you think about subtraction, subtraction is not commutative like addition. So on the ellipse, we could change the position of the x and the y. Do you notice, we didn't change the position of the x and the y, but we did change the position of the a and the b. On the hyperbola, we don't do that. A and b remain stationary, and the x and the y are going to flip. So if, on this first example, your x variable is first, then that means that your hyperbola is going to cut through the x-axis. If, on your second example, the y variable is first, that means your hyperbola is going to cut through the y-axis and he's going to be laying down more horizontal. The last thing we need to really know here is that the foci, they are still c units from the center, but this time your relationship is that where c squared equals a squared plus b squared. That is your relationship to find where your foci are. It's not subtraction anymore, it's now addition. Example 1. Graphing an equation of a hyperbola, graph the equation of x squared divided by 4 minus y squared divided by 5 equals 1. Then identify the vertices, foci, and asymptotes of the hyperbola. So first things first, I know the center of this hyperbola is at 0, 0 because I don't have any h's or k's or weird things going on. Then if I look at my standard form, this time this is always A and this is always B. A and B are no longer switching. The first one is always A, the second one is always B. In this case, A is going to be 2 and B is going to be 5. Now, because the A is underneath of my x squared, that's telling me on my x-axis or parallel to my x-axis, I'm going to go out 2 and 2, which does get me my vertices. So for the sake of labeling your vertices, I'm at positive or negative 2, 0. Now, as for the 5, that's underneath of my y, so I'm going to go up 5, and I'm going to go down 5. And this guy does not have co-vertices, so we're not going to label those. But what that creates for me is it creates this box. And we're going to draw that box with a dotted line, because this is going to tell you how to graph your hyperbola. Now, do you notice on your box from your center you have corners? Well, those are your asymptotes. So we're going to go out the corner, and we're going to go out the corner, and then we're going to go out the corner, and we're going to go out the corner. Now, what you just created was you created where your hyperbola is going to lie. And the question becomes, is he going to lie in here, or is he going to lie up here? And the way you figure that out is you go and look at where your a is. Do you notice that your first variable in the equation is x? So because it's x, this guy has to cut through the x-axis. So here are your vertices on the x-axis that he's going to cut through. You come from your vertice, go up the slanted asymptote. He kind of rides along. Come down and ride along. You don't want to cut into that dotted line. Same thing over here. He's going to go up like that. He's going to come down like that. So that's how we're going to get the graph of our hyperbola. Now, the next thing we need to find is we need to find our foci. And your foci are going to sit somewhere out in here, because this on your x-axis is your transverse axis, which is connecting your vertices. So we know our foci are somewhere on there. Our relationship is that c squared equals a squared plus b squared. So a squared was 4, b squared was 25, so c squared is 29, which means c is plus or minus the square root of 29. Now, for the sake of our foci, that means from the center, we're going to go plus or minus square root 29. But this is roughly 5.385. So roughly 5.4. So 5.4 would be right here and right here. So that's where your foci are on your graph. Just like your parabola on your left-hand side, it's kind of on the center of that guy. And then on your right-hand side, he's kind of on the inside or center of that guy. Last but not least, we need the asymptotes. Now, asymptotes are the equations of the lines, and they're of the dotted lines. So those dotted lines right here that we have in red, that's your asymptote. This one is your other asymptote. It's the line that tells you how to draw the parabola. They are lines. So remember, y equals mx plus b. M is your slope. Slope is rise over run. If I start from my center and I rise 5 and I run 2, 5 over 2, I get y equals 5 halves x plus b. B is my y-intercept, and in this case, I'm at the origin, which is 0, so plus 0. Now, you also have the other one that rises 5, but goes backwards 2, which is negative. So you'd also have y equals negative 5 halves x. So the way we're going to list that in this case is just y equals plus or minus 5 halves x. Example 2. Graph the equation of that hyperbola. Identify the vertices, foci, and asymptotes of the hyperbola. Now, if I'm looking at this guy, we have a problem. And the problem is that he's not equal to 1. So before we can actually do this, we need to make this equal to 1. And in order to get 1, I have to divide by 144, which means I'm going to divide everybody else by the same number. When I do that, 16 divided by 144 is going to get me 9. So y squared over 9. minus x squared over 16 equals 1, and that is the standard form of our equation. Remember that a and b are no longer switching, so the first one is a, the second one is b. Before I even do that, I know that my center is at 0, 0, so I'm going to put it on my graph. Now a is going to be 3, and notice that 3 is now on your y-axis. So we're going to go up 3, and we're going to go down 3. Then we're going to get b, which is 4, and that is on your x-axis. So we're going to go out 4, and we're going to go out 4. At this point, we're going to create our box. Then we're going to go from our center out the corner of our box. And then we have to figure out which direction this guy is. So because the y squared is first, that means he's going to cut through the y-axis. So he's going to be laying on his side. So from this first vertice, I'm going to come from my vertice, go up my asymptote, go up my asymptote, and then down my asymptote, down my asymptote. So this guy's kind of horizontal, cutting through the y-axis, which means the vertices are the ones you just crossed through, which are at 0 plus or minus 3. Then we have to go find our foci, which are going to lie on our transverse axis, which this time are right there. So c squared equals a squared plus b squared. A squared we know is 9, b squared we know is 16, so c squared is 25, which means c is 5. So if I wanted my vertices on my graph, I would go up 5, or I'm sorry, my foci, and I would go down 5, and there's your foci, which means we have 0 plus or minus 5. Last thing we need is those asymptotes. So those asymptotes are those dotted blue lines. We've got y equals mx plus b. I'm going to start at my center. I'm going to rise. I'm going to run. I rose 3. I ran 4, which those numbers better be coming off your a and your b, because that's how you created it. So because I rose 3 and ran 4, I could also rise 3 and go backwards 4. So one's the positive, one's the negative. Y equals plus or minus rise 3, run 4, x plus b, but because we're centered at the origin, it would be plus 0. So that's the equation of your asymptotes.